Okay, here I am. I'm back. I'm back in exile again. Back over here, where wherever the thing is, in my shed, in exile because of my other computers being jammed up by some platform. I won't mention the name. Anyways, here we go. Let's get into it. This is just to say that what Jungle Jog has been saying about the timeline thing is not that far fetched. It's not way out there. It's really mainstream science. You just have to do the thought experiments, consider it, and see what's going on. Case in point, we have here uh, a probably a Dr. Spike Ferris. What's his name? Spike Ferris. Anyway, let's get into it. Let's go ahead and play this at a faster speed so we get into it. Where's the play? This is the play. Let's go.
Well, thank you for returning from lunch. That was a nice break. So far, we have talked about 7 assumptions built into the light travel time challenge. We talked about the first 4 so far. We saw that the first one seems to be reasonable, that the speed of light has not changed throughout history. The second one, however, is demonstrably false. The one-way speed of light is not absolute. We don't know what it is because it's unknowable.
One-way speed of light.
Furthermore, we can actually choose to use different values for that depending on the circumstances, which means that an absolute challenge for light travel time is not valid. Option 3 was, or I should say assumption 3 was that the universe was not created mature. We see how that would solve the problem if it were. Assumption 4, that light has always traveled through space as it does today. If that's not true, if the Lord supernaturally accelerated things, then of course that would solve that problem as well. And we finished by looking at what I call the secular dilemma, 6-word question. Who remembers what it is? Did the universe have a beginning? We saw how both answers to that question are going to violate physics in a different way, but this causes problems for secular modelers, but not for us because we know a supernatural creator outside of physics is responsible.
Yeah, you got to go through the whole thing, his whole presentation, just to see all the different models and everything and all the problems with them. And then now he's going to explain what I've been saying for the past year or so, at least. And he's been saying it for the past year or so. I don't know who got it from who. I didn't get it from him, that's for sure.
For the universe. So that catches us up to where we were. Let's proceed further now and explore the remaining 3 of these 7 assumptions. So back to our equation. We are once again going to look at a different aspect of speed, a different assumption built into this equation about speed. We already said that the speed of light apparently has not changed throughout history, throughout time. What if, though, it changes according to location? What if it's variable through space? What do I mean by that? Well,
okay, see there? Speed of light changes. It depends on the location. If you do the thought experiments in general relativity, I mean, this is obvious. So obvious.
Where have we measured the speed of light? All of our measurements of the speed of light have been done where? Here on Earth, which is within our solar system, which is within the gravitational field of our sun, and the sun itself is within our galaxy.
And another thing, he's talking about the gravitational field of the sun. I'm talking about the gravitational field of the entire Milky Way galaxy. What? Because we're talking about vast distances. We're talking about huge distances. We're not talking about little. It's not like looking at a cat or a dog, like I said before. It's not like our observations of a cat and a dog. When we look at another galaxy, we're looking at different rates of time and distance, different measures of distance. And then when you get outside of a galaxy, there's no, gravity drops off exponentially outside of the galaxy. Exponentially. So, and especially in the Lagrange point between galaxies, they're pulling on each other. They're fighting each other. If there is any gravity, it's fighting each other and canceling itself out. So there's no gravity, basically, between galaxies.
What about elsewhere? What would the speed of light be outside of our galaxy? We don't know. We've never measured it there. Now, it's usually assumed that it's the same out there as it is here, but some scientists are questioning this. Relativity understands space-time to be a sort of a fabric
Yeah, some scientists are questioning this, and Jungle Jargon from the Amazon is questioning it too.
in a sense in the way that it behaves. We know that a distortion in space-time introduced by gravity, let me simplify the statement. We know that gravity affects the path of beams of light. When light travels by a massive object, it'll actually be bent around that object. Well, what if this same effect would affect not only light's path, but also its speed? Is it possible that light travels more slowly through a gravitational field? More specific.
Of course, when you get close to the black hole, time slows down and distance is contracted. So I've been through this before, trying to explain it. See if Spike can explain it better, or better than me, or not better, but just another way so people can understand. At least two different perspectives talking about the same thing.
Specifically, is it the same in deep space as it is here in our solar system, which again is the only place we've ever measured it? There are scientists looking at this now, and as you can imagine, if light traveled more quickly in deep space in between galaxies than it does here on Earth, then of course that would decrease the time required for light to travel through space to reach us, right? And this is gaining interest not only in the creation community, but secular scientists have actually been looking at this longer than we have. This is called VSOL models, variable speed of light. There are some secular cosmologists who are investigating this as a possibility. Now, their motive.
Of course, they haven't been too public about it or outspoken about it, because you never hear the science promoters talking about it very much. At least I haven't seen them talk about it, because of the implications. It means that the universe can be young, and that we can see distant starlight almost instantaneously.
Is not to explain why the Bible is true. They're trying to solve some problems with the Big Bang model. But my point is, this isn't some fringe idea that creationists came up with. This is actually an ongoing effort on both sides of this debate. So assumption number 5 then is that light speed is constant across space. If that's not true, then of course that would decrease the amount of time necessary for light to.
Okay, this is the thing. It's like Einstein, I've said before, drilled into people's minds that the speed of light, c, is an absolute constant. Yeah, but that's a mathematical construct. It's constant using the math of having constant measures of time and distance, but measures of time and distance aren't constant. So the speed of light is not constant. But mathematically, it appears to be constant, or it is constant mathematically, but that's just a construct. You know, it's not even letting people know that once you get away from gravity, that the measures of time and distance are going to change. It's going to change the speed of light relative to where we are.
Get here. So far we've actually pulled quite a bit out of this equation that wasn't all that clear up front that it was in there, right? You see how there's a lot of assumptions built into this that are indeed built into it, but that you just kind of take for granted.
Now, how many times have I said that if the measures of distance and the measures of, time are, measures of time and distance aren't the same, then the speed is not the same.
We've questioned distance and we've questioned speed. Can we question time? And the answer is yes. So here's a proposed cosmology by some people within the creation movement.
And I don't even know if he's questioning distance too, because if you have to question distance too, because they're assuming the distance is a lot more than what it actually is.
We are used to thinking of creation as happening inner to outer, in a sense. That first there was nothing, then the Lord created the earth, and then the cosmos was created around the earth. What if, from a certain perspective, it happened in the opposite sequence? That the Lord created the outermost galaxies first, and then moving inwards at the speed of light, created the next innermost amount of galaxies, and the next innermost amount of galaxies, and finally the earth in the middle, such that the light from all galaxies in all directions arrived here all at the same time.
Did you hear what he said? He's saying that the other galaxies farther away were made first, while we were running at a slower rate of time. But this is just, one of the possibilities. But even if it was all made at the same time, we could probably still see light from distant galaxies in 6,000 years anyway, because the distance isn't as far as what we think it is or what we're measuring it to be.
On day 4 of creation week. Now, this was from an earth-bound observer's perspective. On day 4 of creation week, the night sky was empty until suddenly it was full. You would see nothing in the heavens except perhaps the moon and the planets. But then all of a sudden, light from all galaxies arrived from here in all directions. So on the 4th day, everything appeared. So from an Earth observer's perspective, that's when creation of all these objects in the cosmos happened. Now, when talking about this idea, many Christians will immediately have an objection. Wait a minute. You're saying the galaxies were created before the Earth, but Genesis says the Earth was created before the galaxies. Well, Genesis does say that, and that would be true from an Earth observer's perspective. But there's more than one perspective that's valid.
Well, I've always said that in the beginning, God created the heavens and the earth, which is everything, including the sun, the moon, and stars. But that darkness covered the surface of the earth, the surface of the deep, the surface of the earth, so that light was not seen on the first day until it was when God said, "Let there be light," on the first day. So the light was already there, but it was made to be seen on the first day. And of course, we're talking about God anyways. We're talking about the creation, and he can do it any way he wants to begin with, which he already talked about it before.
And this ties into another idea here, that we want to treat time as absolute, that there's this absolute sequence of time as shown in Genesis. There's day 1, day 2, day 3, day 4, etc. From a galaxy's perspective, things would happen differently. From the galaxy's perspective, it was created first. The other galaxies around it were. Some of the outermost galaxies wouldn't actually be able to perceive the Earth yet in a young creation, because light has not had time to travel from here to out there. Whereas from an Earth's perspective, Earth was created first. From the galaxy's perspective, galaxies were created first. Hope I'm not losing anybody yet. The point is, depending on where you are in the cosmos, you would perceive things happening differently.
Right, because he's talking about the slower rate of time in the center of the expansion or whatever. This is considering the possibility that God made everything by expanding everything out of a black hole, which means that we were one of the last things to come out of the black hole, quote unquote black hole, which would require like a huge amount of power to be able to do, overcome gravity of a huge black hole that contained the entire universe in it. And I mean, the whole thing requires a lot of power anyways, which is a huge problem for cosmology, because energy can't make itself, it can't direct itself or order itself the way we see it is today, going from order to disorder.
And this runs counter to our everyday intuition, because we're used to thinking of time as an absolute thing. But it's actually not. For example, are you experiencing this presentation live this morning? You think so, right? But you're actually not. Light doesn't travel infinitely fast. Sound doesn't travel infinitely fast. There's a tiny fraction of a second for my image and the sound of my voice to go from me to you. You ever think about that? So you're actually experiencing a delayed version of this presentation. Now, in this case, the delay is so small that it doesn't matter, so you don't think about this, right? In astronomy, though, it does matter. For example, when Venus does a transit of the sun, in other words, where that little dot there is the backside of Venus, Venus once in a while, not very often, but once in a while, will travel in between the sun and Earth, and we see what's called the transit. Can you experience this event live? Well, you'd think so, because you can look up on the NASA site when the next one will happen, go outside and look at it. But actually, it takes time for sunlight to get from Venus's location to us. In a sense, there's a time delay. When you see a solar eclipse, like the annular eclipse that happened the other day, if you got to see that, did you see that live? Or did you grumble and say, there's a 1 second delay between the time the light got from here to there, and I wish I could see it live, but no, I'm watching a movie. No. You treat it as if it's a live event, right? You treat it as happening when you experience it. In similar fashion, from an Earth's perspective, the night sky was empty, suddenly it was full. From an Earth perspective, the galaxies appeared on day 4, so that's essentially when they were created. You're not trying to impose some absolute time scale because you realize it's different for different locations. And we even the conventions we use. I mentioned earlier that there's supernova 1987A happened in 1987. But if this thing is 168,000 light years away, why didn't we call it supernova 166,000 DC?
Okay, this is going to take longer than what I have time for to go through, but of course, everyone can watch this on their own. This is the part two. In the part one, he went into it toward the end. He went into the same thing as what I was talking about, that there's no absolute measure of time or distance, which alters the speed of light depending on where you are, or depending on where the light is in its transit. And most of the time, the light is in transit between galaxies, which is not affected by gravity as much, considering that all the other galaxies are all pulling. So basically, everywhere in between galaxies is a Lagrange point between all the other galaxies that are all pulling on it, all over the universe, right? So if you have all the gravity pulling on itself, it's going to cancel itself out from all over the universe. And people, do they think about this stuff or talk about this stuff? No. It's just only Jungle Jargon has been talking about this stuff. Shalom. Chill, how you doing? Um, there you go. Joe said he was going to join, talk about genetics, but he might have time, and I don't have time today, but someday maybe we'll talk about genetics because he seems to be interested in that, because I'm interested in that as well. But I got to get ready to go work now, and but sometime maybe I'll have more time. I just had a problem this morning because some platform, I won't mention the name, was jamming up my computer, so I couldn't even display a video stuff. But anyways, let me see. That's about it. There we go. Okay, so God bless everybody. Take care, and remember, there's nothing to worry about. Fear not, you saints of God. There's nothing to worry about, nothing to make you feel afraid, nothing to make you doubt. Remember, Jesus never fails, so why not trust him and shout? You'll be sorry you're worried at all tomorrow morning. God bless and take care. There you go. See you next time. Have to go to work also. There you go. Yeah. We got work to do. We're busy. Busy people. Got important things to do. God bless everybody. Take care. Stay close to God, and you'll never go wrong.